Okay, please open your book to page 555. This is lesson 3, triangles. And make sure that you've got some writing utensils because you're going to be asked to do a few things along with me. So we're going to start out with this real world problem. It says ramps. Julia practices jumping on a ski ramp. The front of the ramp is a triangle like the one shown. Draw an X through the type of angle that is not shown in this picture. So I'd like you to X out which angle is not shown here. So we have right, acute, and obtuse. So is there a right angle? Yes, there is, because of this notation right there. That's telling us that that's 90 degrees. Is there an acute triangle? Well, acute means something smaller than 90, so there is one of those. And obtuse. Obtuse is more than 90 degrees. Well, notice that we don't know how many degrees this is, but by logic you can see that it's definitely not a 90 degrees. It's not a straight corner, and it's not more than that. It's smaller than that, so that one has to be acute too. So obtuse is the one we'd cross out. Okay, so then we're asked to measure this. Well, to measure that, we'd need a protractor. So I'm going to grab my protractor here, line up this dot with the bottom, with the vertex right here along the bottom. We start with 0 down here. So we move up and notice that this line comes through right here at 10 degrees. Now how do we know that it's not 170? Well, we use logic. Logic tells us that this small little angle cannot be over 90 degrees, so we know that this is 10 degrees. Okay, so now let's write out all of these angles that we have. We have an 80, we have a 90, and we have a 10. Notice that when you add those up, those equal 180 degrees. That is one of our concepts today. Every time you draw a triangle, the three angles always make 180 degrees. Okay, so now with the straight edge, I want you to draw a triangle that has one obtuse angle. So to be obtuse, we need to have an angle that is greater than 90 degrees. Okay, so if you have to pause the video to go get a straight edge, please do that. And notice that this angle is definitely more than our 90 degree straight corner. So this is called an obtuse angle. So we would call this an obtuse triangle. That's how we would classify that triangle. Okay. Notice that when you have an obtuse angle, the other two angles are much smaller than 90 degrees. Here and here, these are both acute. So the next question is it possible to draw a triangle with two obtuse angles? Okay. So if we had an obtuse angle here, is it possible over here to have another obtuse angle? Would that make a triangle? As you can see, if both the angles are obtuse, the two edges are going in opposite directions. They're never going to touch to become a triangle. So it is not possible. So if you need to pause the video to complete any of these sketches, please do that and make sure that you kind of take a minute to absorb what's going on here. When we turn the page, we're going to deal with classifying triangles. And there's two different ways to classify triangles. You can classify a triangle by their angles. So this top row is how we classify a triangle by just looking at their angles. So we call something an acute triangle if all of the three angles are all acute. If they are all less than 90 degrees. We call a triangle right if there is one right angle. and we notice right angle by this straight corner marking. We call that a right triangle. And it's an obtuse triangle if there is one obtuse angle. The next way to classify triangles is by looking at their sides. The side lengths, we're looking at how long the sides are. So if there are no sides that are the same, no congruent sides, we call it scalene. Now this is kind of hard to tell, but technically this side is a little bit shorter than this side, and neither of these two sides are equal to this side. So we would mark them all with different dash marks. So this means this, and this are all different. So please add that in. It's going to be isosceles if two sides are congruent. So notice for two sides being the same, we would use the same dashing mark. So that's saying that this side and this side are the same length. So for instance, if this was 9 centimeters, this side would measure 9 centimeters. That makes it isosceles. And equilateral is when all three sides are exactly the same length. So if we had 5 centimeters, 5 centimeters, 5 centimeters, that would all measure. Now, when you're asked to classify a triangle, you're going to want to use one of these classifications and one of these. Okay, so off to the side here, I'm going to sketch this triangle. With these marks here. And we're going to classify it. So first look at the top row. The top row, is this acute triangle? Is it right or is it obtuse? Well, because of the right angle, it's a right triangle. And based on the sides, is it scalene, isosceles, or equilateral? Well, since all three sides are different, we would call this a right scalene triangle. Okay. Alright, so down here you're going to be asked to draw something. So if you can please pause the video. I want you to use a triangle, or a straight edge, and I'd like you to complete this got it question. Make sure that you mark everything that you intend to show. So if it has to have a right angle, you need to have some marking to show a right angle, like up here. If sides are supposed to be congruent, you will use these dash marks, either single dashes or double dashes, to show that they're congruent. Okay, top of the next page. Classify the triangle on this house by its angles and by its sides. Well, since this is not marked as a 90-degree angle, we cannot assume that. So if you look carefully, this looks like it's slightly bigger than 90. So that would make it obtuse. And since this side of the roof and this side of the roof are the same length, it's isosceles. So that's an obtuse isosceles triangle. Okay, please pause the video and answer this question. Okay, the next theorem we already alluded to in the beginning. This is telling you that in any triangle you have, the three angles will always add up to be 180 degrees, no matter what they are. And so we're tying this into our solving equations problem. So if you notice this triangle, we have 119 degrees, 43 degrees, and this one's not measured. So that's kind of our unknown. That's our variable. Okay, so we set up this equation and we solve to get 18 degrees. So please pause the video. I'd like you to set up an equation, show your work, and solve this. Turn the page. And to finish up this video, I would like you to do 1, 2, and 3 in guided practice. I will check that first thing tomorrow.